I have found that substitution, for whatever reason, is more confusing to you than elimination and graphing. So I'm going to step you through it a little bit. I'm going to give you a little recipe about what you should be looking for and what you should be trying to do, and then we'll go through some examples. Okay? So first thing you're going to do is you have to get one variable by itself in one of the equations. Now, keep in mind, there are times, and you'll see an example like that, where this has already been done for you. When this has been done for you, it makes it a lot easier. And when this has been done for you, oftentimes when you get to the place where you can choose which method you want to use, because on your quiz you're going to have to show me that you can do each of the three methods. But after that, it's going to be up to you. Okay? When you have a situation like this, more often than not, you want to use substitution, even though you love elimination better than the other ones. Okay? So that's my first move. Get one variable by itself in one of the equations if it isn't already done for you. The second step, now here's where it gets a little wordy, and it'll make a lot more sense when we go through the example. You're going to substitute the expression that's on the other side of the variable that you got by itself in the other equation that you haven't used yet. It's totally wordy. So here, let's say I get y by itself. So what's on the other side of y gets substituted into the other equation that I didn't use yet. And like I said, when we look at examples, this will make more sense, and when you go through it a few times, you won't even need to look at this anymore, but I just want to make sure we all kind of get on the same page first. So the next step is, now that you've plugged that other side of the equation into the second equation, you have one equation with one variable. Okay? And you just have to solve that equation now. When you've taken that other expression and substituted it into the other equation, you have to now solve that other equation. So in theory, if you plugged in and your new equation only had x in it, then you solved for x. Okay? And once you do that, it's just a matter of the process is the same as what we did for elimination. You take that, you plug it in one of the equations and solve. Except, I want you to plug it into the equation, an original equation. And I want you to plug it into the first original equation that you used to solve for the other variable that you don't know. Okay? Here's why this is important. I want to make sure that you plug it into the first equation and not the same equation that you just used, because sometimes what will happen is if you make a mistake in solving for the first variable and you plug it back into that equation where you made the mistake, you could get another wrong answer. So a lot of times what will happen is when you plug it into the first equation again, or the one that you used first, I should say, you'll catch a mistake. I'm going to put an example up, and if you feel like you know how to do solve a system using substitution, you can just go ahead and solve it. Okay? I'm going to give you a few minutes to try, and then if you're stuck, then it'll help, because then we'll go through it all together. Okay? Raise your hand if you remember doing substitution before. Okay, that's good. So let's do that. I'll put the system up. You go ahead and give it a try, and then we'll come back and do it together. Okay? So here's the system. Go ahead and solve that. Remember to express your final answer as a point, an ordered pair. First one, since this one's set up nice because I already have y by itself, so which means I know that y equals 2x plus 5. So that first step is done for us. Okay, get the one variable by itself. Now, here's where my words were crazy, right? The expression, and that's what I've circled, on the other side of the variable that we got by itself, we substitute into the other equation. Keep in mind, if we have one equation with two variables, I can't solve it. But if I have two equations with two variables, I can, because I'm going to get it down to one equation with one variable. So it ends up looking like this. And so I'm going to solve for x now. I've gotten rid of the y's. I've got one equation, one variable, okay? Jeez. So this is 8x plus 15 equals negative 17. Now, careful, you subtract 15. Signs are the same, so you add. 8x equals negative 32. Okay? I'm just going to put this up here. So x equals negative 4. Now, here's what I was talking about in that last part. I want you to take this variable that you found and plug it into the first equation you used. I don't want you to plug it back into this equation. Now, although if you do it right, it comes out just fine, if you make a mistake somewhere in here and you plug the wrong number in to the same equation, it's going to seem like you did it right. Okay? So that's why we go back to the other equation, because it can kind of check for us. Plus, I already have the y by itself, so if I just plug the negative 4 in, I'm going to be in good shape and can finish it up. So y equals 2 times negative 4 plus 5, and this is the step that's the same whether it's elimination or substitution. So y equals negative 3. My final answer, negative 4, negative 3. How many had that? Okay, good. Are there any questions about it?
Mm-hmm.
Yes?
In that first problem, was it y equals and it was the other way around and we changed it so the variable equals an equation? Then do we plug that number back into the original one or the one that we changed?
Original. Always use the original equations when you try to find the other part. So that's a good question. So in the next example, it's gonna come into play. Always use the original one because we know that the original equations are right. As soon as we start altering them, that's where we create possible errors. And then if we plug them into equations that we've made a mistake to, we could double down on our mistake. Yes?
Which original equation do we plug back in?
So
Top and bottom.
it depends on the problem. So since I plugged basically one equation into this equation, I go back and I use the one that I didn't use.
Okay.
Okay?
But it doesn't matter? Like you could plug it
If
into
you
the
do,
bottom one?
you could. If you do it right, you'll still get negative 4, negative 3. Like what I'm saying is there's lots of opportunities to make mistakes in here, and if you make one, a lot of times by plugging it into the other equation, you'll catch it.
So it's...
Let's look at another one. Here's another one. Okay? Now, let's get that down and let's talk through this one a little bit. Here's the issue with this problem that we didn't have with the last one. I don't have a variable already by itself on one side. Okay? Now, technically, it doesn't matter what variable you decide to get by itself. If you want to get this y by itself and then take what you get there and substitute it in here, that's fine. Okay? If you want to get this x down here by itself and then substitute up in x for this one, it's fine. But what I want you to look for is something that's going to make your life as easy as possible. All right? Because if I try to get this y by itself, eventually I'm going to have to divide by negative 3. Everything by negative 3. If I get this x by itself, I'm going to have to divide everything by 3. If I get this y by itself, I'm going to have to divide everything by 4. Look for situations like this. Because in one move, I can get x by itself without having to do any division, right? Because if I rearrange this equation to have x by itself, what is it? Yeah. Okay, so right here, I can make this 4 plus 3y, 3y plus 4, they're the same thing, okay? And I don't have that second step of dividing everything by the coefficient, the number in front of the variable. And so by doing that, if you look for those things to save yourself some time and energy, okay, that's going to make your life easier. So I'm going to take this now and substitute it in for x in the other equation. So now go ahead and finish it. Here's what we get. I get 3 times 4 plus 3y plus 4y equals 38. That's 12 plus 9y plus 4y equals 38. That's 13y subtract the 12 equals 26. Y equals 2. Now, here's where I'm saying. So now, I know you were inclined and you thought I'm going to plug it in here because I already had x by itself. You really should plug it into the original equation. Okay, you should really plug into this one because that's the one I didn't plug into. Now, again, if you don't make a mistake, it's not going to be a problem. Okay? If you make a mistake, that's where you run into a problem. Okay, so final answer 10, 2. How many had that? Good. All right. Now, so the last two problems, there was sort of an ease. The first one was set up for us to do substitution. And honestly, if you have a problem, if you encounter a problem like that in a test or quiz where the variable is already by itself, even though you might love elimination, it's trying to tell you use substitution. Okay? It's set up for you if you save some time and energy. Now, this one was almost set up for us that way. Just we were one step away from it being already set up for substitution. And then there's going to be problems that aren't set up that way at all, like this one. Okay? There isn't a variable alone sort of by itself that in one move I could get by itself. They all have a coefficient other than 1. They're all being multiplied by something. Now, before you just jump in, I want to tell you that there's one variable that if you get by itself will make this problem easier on you than the others. And before you do it, don't say it. I just want you to kind of analyze it and see if you can figure out which variable would make more sense to get by itself than any other of them. Think about it. Do not say it out loud. Let's think about this real quick. Okay? I'm going to start with the bottom equation. Okay, if I wanted to get the x by itself, that would mean at some point I'm dividing everything by -7. 9 by -7, 13 by -7, not nice, not clean. Same thing over here. If I wanted to get this y by itself, okay, I'd end up with -7/9 somewhere and 13/9 again. Not nice, not clean. If I go up here, we're getting better. If I divided by 4, I'd have 1/2 and -1/2. But if I get this y by itself, I'm going to end up dividing a 4 by a 2 and a 2 by a 2. Now, here's the thing that I want you to take away. All of those things will work out just fine. If you just always want to get the first one by itself, go for it. Just know that if you can save, because I know how much you love fractions and negatives and all that stuff, you hate them. So if you can avoid it, I encourage you to look for a way to avoid it. It's not always avoidable. Okay? Question?
Wouldn't it be dividing by -2?
Yeah, I want to get this y by itself.
Boom.
Okay? Because then I'm dividing by -2, which means 2 by -2, -4 as it turns out by -2. Those will give me integers, and I won't have to deal with fractions yet. So here's what this is going to look like. Okay? So I have -2y equals 2 minus 4x. I just subtracted 4x from both sides. And now I have to divide everything by -2. Each term. Some of you on your test only, you skipped one of the terms. You gotta divide everything. So this gives me y equals -1 plus 2x. Okay. So once I've done that, I can take this, substitute it into the other equation. Now, one of the things I want to warn you about, sometimes you plug into the same equation, and that's a mistake that you'll make. So like, for example, instead of plugging in to the other equation, I'll see people plug it into the same equation they just rearranged. When that happens, everything cancels out. So if that happens to you, and you're not sort of at the end of the problem, know that you probably plugged it into the wrong equation. You plugged it into the same equation. Okay. All right, so let's finish this one up and let's see what we get. Okay, so when you're done, take a look at the screen, see if you got the same thing as me. Now,
Yes.
I want to talk about how to check your solution. Okay? Because you can check your solution. Sometimes you are going to have to. And the way you do that is what you're going to do is take your point, and this works for whether you use substitution, elimination, or graphing. It doesn't matter. What we're saying is that this point satisfies both equations. So if you plug 2 in for x and 3 in for y, in this first equation, the left-hand side should equal the right-hand side after you simplify. The same thing should be true for the second equation. If you plug 2 in for x, 3 in for y, and you simplify, okay, you should get the left-hand side equal to the right-hand side. So if you're ever asked to check, or if you want to just check for yourself to make sure you did it right, all you've got to do is make sure you plug it into each equation, simplify, make sure the left-hand side equals the right-hand side, and you're good to go. Okay? Any questions?